All right, let's finish this. Practice 2. So remember, Thursday, Friday this week is your final. No multiple choice questions. All right, so subtract this from this. This is a trick question. From goes in front, so I need to just put this first. Minus, subtract. Always draw a subtraction. That doesn't make sense, so it's got to go in the back. Then I'm going to do my state change switch. Find my terms. I get negative 3x squared minus 3x plus 3. Done. All right, what's happening? Flip x-axis. Right? This is going to go positive 1, so this is going to go left 1, and then that's going to go vertical shift up 4. So then let's do this. Horizontal shift. Let's go left 1, vertical shift up 4, flip x-axis. All right, so again, parent graph is the parabola, right? 1, 1, 2, 4, just numbers squared. So now I'm going to take it, I'm going to flip it upside down. So what I would do is go like this first. Then, let's see if I can do this. Get my pointer. Let's move it left 1 and up 4. 2, 3, 4. So it should look like the green one. All right, done with that page. All right, so it's given the function showing what's the value of f of 2. Again, so this just means what's the y value when f is 2? So 2, y value 4. So it's really the point 2, 4. You're just telling me what the y value is. That's all it is. Where is the y value 0? So our y value is 0 there. So there, there, there. So you're going to tell me what x values. So how many? So 3. On the interval from 0 to 5. So as I go from 0 to 5, 0 to 5, what's happening? 2, 3, 4, 5. Right? It's going down. It's decreasing. How can you tell? The y values are getting smaller. So obviously it is going down. Is the inverse of this function a function? Remember, inverse is when you switch it x and y. So that answer, this original one is not 1-to-1, right? It fails the vertical line test. Therefore, its inverse will not be a function. No, it will not. Baseball player hits a time, right? All right, so again, you're going to see one of these. First thing I want you to do, if you can graph it, if you really want to, it's going to kind of look like this. 1, 2, 3, 4, and then it's going to go up. There's your ball. So first thing, what time x value is it at its highest point? Right? What time is it at its highest point? So you can plug in your calculator, look at your table, find that. It's not always going to be a nice point. This one happens to give you a nice point. So you could look at your table, and then it's probably going to happen right here at 2. At 2, you're going to get 68 feet. And say this one is like 65. I'm just making these numbers up. But this is going to be its highest point. Or here's algebra. X equals negative b over 2a. So I'm going to go negative 64 over 2 times negative 16. And that's going to get me 2. Here's my time when it's at its highest point. What is the baseball's highest point? I then plug 2 in. Right? I evaluate that. I get 68 feet. When will the ball hit the ground? So again, that means I'm just taking this equation and setting it equal to 0. All right. I would do the quadratic formula. I'll just plug it in. So 64 plus or minus 4,096 minus 4 times 46, or sorry, 64 times 4 all over 2 times negative 16, right? I do that, I'm going to get two answers. One answer is negative 0.06. Could the ball hit the ground before it was even hit? No. So the other one gets me 406. And then what's the height of the ball when it's hit by the batter? Right? So negative 16 t squared plus 64 t plus 4. That answer is right here. That batter hit the ball 4 feet off the ground. Whatever your C term is, that's how high the ball was when you hit it. All right, and the last one. Cup of coffee. Starts at a temperature of 126. The coffee's left outside where the temperature is 36. After 10 minutes, the hot chocolate's 72 degrees. Okay. The Fahrenheit temperature is that, right? So ready? A is our starting temperature, 126. B. We're going to solve for B in a second, so let's just put B in. Things we know, B to the T plus C, right? C is your ambient temperature, your temperature outside, 36. Okay, and now we know, so we know, oh, that's really F and T. So then, they tell us right here, a point in time, at 10 minutes, B to the 10th, right, we're going to have 72 degrees. So now I'm just going to plug in a couple things. Right? I'm going to subtract 36 over, divide by 126, take the 10th root of that. Right? So when I subtract that, take the 10th root, I'm actually going to get my B, right? So minus 36, get that answer, divide by 126, and then I'm going to take the 10th root of that answer, right? Because that's B to the 10th. How do we solve it? We take the 10th root. Oh, what an answer is, this gets me B to be nearest 10th we're looking for, 0.8822, so that's 0.9. So the value of C, right, is the temperature of the C is 36. Value of A was 126, the starting temperature of that object. And then B, we just solved for it, was 0.9. Now, if we know all that stuff, how long will it take the cup of coffee to get at 45 degrees? So I go 45, and I'm just going to plug it in that formula. I'm going to subtract 36 over. So what does that get me? 9 equals 126.9 to the T. Please don't multiply those two numbers together. Divide by 126. So now I'm going to get something. So 9 over 126 equals 0.9 to the T. All right. This is a little log question. When the variables in the exponent, I'm going to take the logs of both sides. Why do I do that? So I can bring that down in front. So I'm going to have T, that's a log, 0.9 equals log. You could convert this to a decimal. I'm just going to leave it like that. I don't want a decimal. calculator right now. Now I'm just going to divide by log of 0.9. This gets me about 25.04 minutes, aka about 25 minutes. All right, there's part 2.